Hello everyone and welcome to the session of data science. In the previous session we have learned about some basics of logistic regression. Today in this session we are going to implement logistic regression model using R. Before moving ahead, I'd like to quickly introduce myself. I'm Neha Ocha and I work as a software engineer in Keypro Solutions Private Limited. Keypro is a leading provider in the field of analytics, data lake, machine learning, artificial intelligence, blockchain, IoT, cloud and mobile applications development. So let's look at the topic which we are going to cover as a part of today's session. So as we are going to implement logistic regression model in R, so we will first install and load the packages required for logistic regression. Then we will explore our data set. Then we will visualize the data set for the missing data, and finally we will fit our model using GLM function. So let's get started. In R, we use a GLM function for logistic regression. GLM function is used to fit generalized linear models, and it is specified by giving a symbolic description of the linear predictor and description of the error. So for this session, we are going to tackle an example of binary logistic regression, and for that we are going to use ISLR package. ISLR package will have all the data sets that which we require for this particular problem. So here in these two steps, I am installing and loading the ISLR package. Here in this first step, I am installing the ISLR package using install packages function, and here in the second step I am loading it using library function. For this example, we are going to use market dataset. This dataset shows daily percentage return for the S&P 500 stock index between year 2001 and 2005. So since we have already an inbuilt dataset, let us first explore dataset and get to know our dataset. So for exploring our dataset, here we are using various functions. The first function we are using is the name function. This is used for returning the name of the column present in our dataset. So here we have used the name function, and in the argument we have passed the name of the dataset. So let me run this and show you. So here we have these 9 columns in our data set. So we are using here head function, and this will return the first few rows of our data set. So we'll get to know how our data look like. So here head function is returning our first few entries of our data set. Now we want to know the total number of rows present in our data set. So for that we are using nrow function, and in the argument we are passing the name of our data set. 1250 is the number of rows present in our data set. For number of column we have to use n column, and in the argument again we have to pass the name of our data set. So we have 9 number of columns. And the summary function we are using for returning the minimum, maximum and mean median of each and every column which has integer values. For the columns which having character or string entries, it will return the total number of occurrence of a particular entry. So here you can see for each column which has numerical values, it's returning the mean, median, minimum, maximum, first and third quartile. While the one column here, the direction, which has string values, it contains the number of entries of each string. So this is the use of the summary function. So by using these functions, we have explored our data set, and we get to know how our data look like and what is the total number of columns and rows present in our data set. Now we'll visualize our data set and see is there any missing value or not. For visualizing and plotting the missing values of our data set, we have to use the Amelia package. So Amelia package has a plotting function called mismap that will plot our data set and highlight the missing values. So these are the steps for installing and loading our Amelia package. So since I have already installed and loaded it, so I'm not going to run these two steps. Here in this step, I'm using the mismap function to plot the missing value of our data set. in the mismap function, the first argument I am passing is the name of our data set. The second argument I am passing is the color. This is taking blue and the red color. So blue color will be used to plot the missing value and the red color is used to plot the observed values. And the third argument I am passing here is the main. Main is used for providing name to our plot. So let me run this and show you, is there any missing value in our data set or not. So here we have our plot and it shows there's no missing value. So in case of the missing value, we use a different approach. And the most common approach is replacing the missing value with the average or mean or median of the present value. So we have explored our data set. We have visualized our data set for the missing value. Now the next step is the model fitting. So before starting with the model fitting, it is advisable to divide your data into two portions. The first portion is for training your model and the second portion is for testing your model. And it's a practice that your training data set should be larger than your testing data set. So here I have divided my data set into two parts. First one is train and the second one is test. So in train, I am passing the first 1000 entries of my data set, and in the test, I am passing the next 250 entries of my data set. So let me run these two steps and divide my data set. So we have divided our data set into train and test. Now I am using GLM function to create my first model, and the name of my model is model1. In this, the first argument is a R formula. And this case, formula indicates that direction is the response while lag and the volume are the predictors. Second argument, we are passing the data. Here we are passing the train data, which will provide the values to these predictors. And in third argument, family. In family argument, we are passing binomial. By this, we want to make it clear that we want to fit a logistic regression model. Let me run this step and create our model. So we have created our model. Now we will use the summary function and this will return estimate, standard errors, z value and p value for each of the coefficient. So here you can see it's returning estimate, standard error, z value and probability for each of the coefficient. And also it's returning the null deviance, residual deviance and AIC for our model. Here you can see there's no much difference between null deviance and residual deviance. Now we will predict the model for the training data, and for that we are going to use predict function. The first argument in the predict function is the name of our model. The second argument is our train data, and in the type we are passing response. So whatever returned by the predict model, we are storing in this variable called predict mod1. So we have executed our predict model step. Now we'll check for the probability of our model. So here we are using if-else condition, and we are passing this condition where if the probability is greater than 0.5, then we are setting it as up, else it is down. So let me run this. Now I am storing that the above data into a table to visualize it clearly. This table is called confusion matrix. According to this table, so here in our data 178 entries has direction down, and our model is also returning it as down. In our data 315 entries has direction down, but our model is showing them as up. In our data 162 entries has direction up, but our model is showing them as down. And 345 entries has direction up, and our model is also showing them as up. So this is how our model is behaving. So let's calculate the error rate of our model. So here we are calculating the error rate, error percentage on our trained data, and we are dividing the error percentage we have calculated by the total number of entries in our trained data. So let me run this. So our error percentage on trained data is 47.7%. Now we will test our model for testing data. So we'll follow the same step, just in the data we'll pass our test data. So let me quickly run these steps. So for our test data, this is the confusion matrix it is returning. So here our data has 76 entries which has direction down, and our model is also showing the same. 33 entries has direction down, but our model is showing them up. 97 entries has direction up, but our model is showing them down. And 44 entries has direction up, and our model is showing up. So error rate in case of test data is 52%. So this is quite high. So here, while modeling, we have taken all the lag 1, lag 2, lag 3, lag 4, lag 5 and volume as a predictor. And when we have calculated the error rate for both the test and the training data, the error rate is quite high. So this high rate of error is not acceptable. So this can be due to overfitting. What we can do, we can create one more model by taking few of the predictors, and then we will try it and calculate rate. So this is the hit and trial method. This you have to check how you can do it and what is the best predictor which we can use for our model. This is how you can design logistic regression model in R. That's all for today's session. In the next session, we are going to start with the classification and we'll learn its use cases. Thank you for watching this session. You can provide your valuable feedback in the comment section. You can also write us at feedback@kpro.co.in. To learn more about new technologies, you can subscribe our YouTube channel on blockchain, cloud, data science, ETL, data lake, DevOps, big data testing, and cloud testing. You can also follow us on YouTube, Facebook, LinkedIn, and Twitter. Thank you once again. Let's keep learning.